Now, my students, let us proceed. And we are going to look on features. We are still in transverse wave, and now we are going to look features of the transverse wave. Before looking to the features of transverse wave, let us have the previous illustrations which illustrate about transverse wave. Remember, in the transverse wave, this is wave direction and this is particle directions. Now let us go back to the features. The features of transverse wave are as follows. Normally, obvious there are two. One of the feature is called crest or peak. Now this is the first feature, which is this one here, which is called a crest or a peak. A crest or a peak is this one here. Now this is the first feature of a transverse wave. The first feature is crest. Can be this one or can be this one, but I decided to put that way. There is no problem. The second feature is called trough. Therefore, we have two features in a transverse wave. We have the upper peak, which is called crest, and also have the depressed peak, which is now we call it trough. Now let us now discuss what does crest and trough means. Now let us begin with crest, which is sometimes called peak. If you will be asked to define what is crest or peak, is the same. From the diagram, you can see that a crest is the region of maximum upward displacement. Therefore, this is the definition. The region of maximum upward displacement, the region of maximum upward. Upward means positive. Remember, this way is positive. Therefore, the maximum displacement, which is positive displacement of matter. Remember, matter is displaces from its original position to maximum point. That maximum point is what we call a transverse wave. Of matter is very, very important. The maximum upward displacement of matter, not of a wave, but it is of matter. In a transverse wave is called crest. Now I think you can imagine what is trough is. This is crest, but I think now you can define what is trough is. Another feature is trough. Now because we have said this is upward or positive displacement, trough is maximum downward displacement, region of maximum downward displacement of a matter in a transverse wave is called trough. Now the formation of trough and crest on a transverse wave has effects to the matter, Now let us look the effects which is caused by crest and trough to the matter or to the area or to the particles. Once trough and crest are formed, the following are the effects which can result. The first, once crest and trough are formed, the following are the effects. The first effect, and mind you, this part is very, very important. The first effect is once crest and trough is formed, the shape of matter changes. For example, look here. The water surface, for example, water surface before being disturbed, it is like this way. But after disturbing, water start to move up, particles start to move up and down, while energy is transferring from original position to the end position until when it dies. Now, do you see this shape? The shape number 1 and the shape number 2 are quite different. Therefore, Why? Because this is crest, this is trough. Therefore, the formation of crest and trough changes the shape of matter. That is one. But second, if the matter shape changes, also volume of matter changes. Therefore, the effect of crest and trough is to change the shape of the matter, but also to change the volume of matter. Now, from that point, we have the following to note. Then, due to this fact, we have the following. Due to the fact that transverse wave yields crest and trough, crest and trough changes shape, but also changes volume of matter. Then we have the following to note. One, transverse wave occurs in solid, for example, spring waves, and merely or retro at the surface of the liquid, for example, water and water waves. I said due to change of shape, due to change of volume, it causes the transverse wave to occur only in solid and merely at water surface. At water surface. But this effect causes the transverse wave to not travel or transfer through gas, and that is one of the most beautiful questions which will be asked. That briefly explain why transverse wave occurs in solid but not in gas or air. Here is the reason. Why do you think so? The reason is, remember states of matter. Which is solid, liquid, and gas. What matter changes its shape? Change its shape. That what matter has shape? That is solid. But liquid and gas occupies the shape of the container. That's why transverse wave is strongly occur in solid, because it involves the change in shape. Now, here is the reason. Why so? It's because gases and liquid do not possess elasticity of shape. The media which possess elasticity of shape, which results, elasticity of shape results into crest and trough, is only solid. Mind you, that is one of the beautiful questions which will be asked to answer. Why transverse in a liquid, not in gas? Because gas do not possess elasticity of shape. Gas change in shape depend on the container. At that point, we have examples of transverse wave. We have many examples, but one of the examples of transverse wave is water wave. If you disturb water waves, if we disturb water surface, what will happen? Matter will start to move up and down, while waves will start to move towards right or left, but perpendicular to the movement of particles. This shows that water waves is the transverse waves. But also have spring or string. I think you know spring in Hooke's law, but also have string in a pendulum. If one end of the spring or string is fixed, for example, we fix one end here. This is the string. But one end, which is maybe this one, is fixed to a pole or a point, and try to shake this one. I think you know I'm not good in drawing. I could draw here a hand which is shaking this spring or string. What will happen? What will happen here? The structure or the figure like this one will be formed. We'll have the up and down movement. Therefore, spring or string waves is an example of transverse waves. The last example of transverse waves is all components of electromagnetic waves, including light waves, radio waves, an example of transverse wave. As I said, the study of electromagnetic waves and its components will be later after deep discussion of mechanical waves. Hope to see you next time. This is the end of our today presentation. Bye.